Okay, we're going to review the quiz we had yesterday. And according to the table, what is the limit as x approaches 3 of f of x? What do we have to remember on this? We have a limit if the limit as x approaches 3 from the left side of f of x is equal to the limit as x approaches 3 from the right side of f of x, if and only if that's the case. And so here we look at the values of the limit here, and it looks like from the left side, if I had to estimate, I would say we're probably approaching 7. I mean, that's kind of what it looks like, right? Mm-hmm. And then from the right, it looks like we're kind of approaching -7. Are these equal here?
No.
No, they're not. And so we say the limit does not exist, because left-hand limit does not equal right-hand limit, okay? And tables are a little bit tricky. Here, the trick is these, if you sort of don't notice the negative sign thing, okay, that's where you'll miss this one. Or sometimes I've seen people choose the x values instead. But the limit of the value of the limit is related to the f of x values or y values. Okay, now 2, what is the limit as x approaches 4 of this relation here? And so you go ahead, if we plug in, the first step is to substitute. So we would put in 4 for that, right? So you'd have 4 minus 4 over 4 squared minus 16, and so you're going to get 0 over 0. So that's a situation where you're going to try to factor and then cancel. So we go ahead and it's quite helpful. If you get 0 over 0 and you have something like this on top, you know that in the bottom that one of the factors is going to cancel. So you know one of the factors in the denominator has to be x minus 4, and the other one is, of course, x plus 4, and these cancel here. And now you can just write this out as just substitute here. Now, one thing that's really tricky here is when you cancel out, you still have 1 left in the numerator, and you're going to have in the denominator 4 plus 4, so you're going to get 1/8 for your answer on this one. I think for a couple of you I saw you had 8 maybe.
Yeah, I did 1.
Yeah, so anyway, it's just something to watch out for. When you cancel something in the numerator, that you'll have 1 left in the numerator. All right? Next, make sure I have this on. Yeah, it works right. Okay, this one here is a similar type of problem. And always, for limit problems, you're going to have limit as x approaches a number, or as x approaches positive or minus negative infinity, right? So here we have this expression here, and if we try substituting, we would have -2 squared minus -2 minus 6. And so in the denominator, you'll have 2 squared plus 2 squared plus 6 times 2 times -2, excuse me, -2 plus 8. And so for this one in the numerator, you have 4 plus 4, no, let's see.
4 plus 2 minus 6.
Plus 2 minus 6, which is 0, right? Is that right, Gavin?
Yes, sir.
And then the denominator, you also get 0, so that's another cancelable situation, right? And so what you're looking for is you're looking to find the limit as x approaches -2 of a factored form of this. Because the thing will only work if you have a factored form, or if you have something canceling here. So here, I don't know what you got. I got like x, is it x minus 3, x plus 2, is that what it is? Yeah, that's it, isn't it? And then you have this, so that's your factoring in the numerator. In the denominator, you have all pluses. So what do you know one of the factors of the denominator has to be?
X plus 2.
Has to be x plus 2, because we have all pluses, and so we know x plus 2 is one of the factors here, and so we just have what's left, which is going to be x plus 4, is that right? And so now that cancels out, and we can now substitute in -2 minus -2 in the numerator, and we have in the denominator -2 plus 4. So we're going to have -5 in the numerator and 2 in the denominator. So this would be our answer here, -5/2. Yes, yeah, okay. Questions on that one? Okay.
So the -2, that came from the fact that it was x approaching -2?
Yes, yeah, what you do is you'd have to, you substitute in -2 for these x's first. And then we did that and ended up with 0 over 0. And so now we factor, and then we substitute in again. And this time we actually got a determinant form, -5/2, okay? This one here, we have, now one thing I've seen in past, I don't know how you did it yesterday, but when you have these problems, like 2 limit problems in a row, some people, I'll see people start factoring this already, but what kind of problem is this really? This is a horizontal asymptote problem, right? Trying to find a horizontal asymptote. And so you look, so you recognize this, and what do you recognize about the numerator and the denominator?
BO2.
BO2. So Aaron recognizes BO2, bigger on top equals undefined. So that would be undefined. I think, I don't know how you answered. I think I was pretty liberal. Some people might have said infinity or something like that, but undefined, okay? Our limit does not exist. Undefined or does not exist, something like that, okay? Next, a 5, the limit as x approaches -7 of 5x minus 3. There's really, this one should be pretty simple. All you can do is substitute in. There's really no other way to go on this. And then, so you have -35 minus 3, you'll have -38. Does that sound right? Okay. Now, this graph here, this is really, and we went over yesterday, this is from the plus side, number 7. But what is g of -6? We go over here to -6, and your graphics were not as clear because in the copying it didn't come out as well. But I showed this graphic yesterday during the quiz, and we don't see anything filled in here, so we would say this does not exist, right? And these are holes, and they should be pretty clearly represented as holes on your graph, even though fainted, okay? What is the limit as x approaches -6 from the right? And I'm going like this, coming over here, and looks like 3 to me. Is that right? That's 3. And what is the limit as x approaches -6? Well, for this one, for 8, what do you have to have when you talk about a limit? Not from the left or from the right. What do you have to have? You have to have left side limit equal right side limit, which you do not have. And so this particular limit does not exist. Next, what is g of 2? And so if you go to 2, we have a vertical asymptote, but here there's a point filled in below. So our answer to this one is -4, because we do have the function defined. what is the limit as x approaches 2 from the right side? Well, x approaches 2 from the right side, we're going towards negative infinity. So if you put like, you could have put does not exist, or negative infinity, does not exist, or negative infinity, something indicates that's right. Now, on this one, on these last three, I had a little bit of trouble from a couple of you on this because kind of the graphics were a little questionable. I want to make sure I get everything here. It's hard to, okay, it's hard to see. I think I got it here. Okay. Now, what happens, the limit as x approaches 7 from the right side, so you come up here to 7, and you have a continuous curve here. So it looks like your best answer here would be 4. I think I had somebody who picked 3.
Yeah, that's me.
It was you? Okay. Well, I gave, yeah, what it was, I considered that, you got credit for that, because I considered that to be like a graphical, insufficient graphical quality type error. Because if you had the graphics like you have here, I'm sure you would have got that right. And so, and what is g of 3? It's 4, so 4, 4, 4, all for.
So you counted my fruits?
Yeah, I counted yours as
Okay, maybe it
correct.
was me.
Yeah, I counted them as correct. Because, and I saw you drew the line
Yeah.
and slanted it down a little bit toward 3, but you had the right idea. So I gave some leniency there. And then for this one here, what is the limit as x approaches 4 if f of x is greater? And one thing you look at is you see an approaching from the left here, which is this greater than or equal. No, the approaching from the left would be this one here. So we have a limit if and only if what? Left, and again, we're talking about the language of they is what?
The
If-
left side and the right.
If the limit from the left, if the left side,
Was equal to right?
if the left side limit equals right side limit. So what we'll do is we'll just set it up like this. The limit as x approaches 4 from the left side of f of x equals limit as x approaches 4 from the right side of f of x. And when I do these, a lot of times I'll put above it just a question mark because we don't know that to be a fact yet, right? And so we just plug this in. We plug in 4 from the left side. So we have 2 times 4 plus 5 on the left side. On the right side, we have 4 squared minus 3. And so on the left side, we have 8 plus 5, which is 13. On the right side, we have 16 minus 3, which is 13. So our answer to this one is 13. And then you could write it out as limit as x approaches 4. I was pretty liberal on the articulation of it. 4 of f of x is equal to 13. Now, one thing that you mentioned talking about AP English is that even though this is not an official AP calculus course, I still use in the instructions and the standards, AP standards. And one thing you do when you actually take a test and you write things out, you just work things out and you don't really box in an answer as definitive. And why is that? Well, the reason you don't is because AP test reader, if they're grading your test, if you go too far and box in a step too far, the wrong answer, they'll say that's it. But so what you do is you keep on writing and working it out, and then if the AP test reader sees the right answer there along the way, and if the calculus is correct up to that point, you'll get full credit for it. So you don't want to restrict yourself. And then this one here, what is the integral from 0 to 4 of x dx? And so for this one here, I think I saw somebody who made a drawing of it. it's like you have y equals x like this, so y is equal to x, and then the limits of the integration are from 0 to 4, and so you have this. So what you have is a 4 by 4 base and height, and so that's going to be 16 divided by 2, or 8. So anyway, that's it. Any questions on this? Okay. Well, I hope that was helpful.